If y is the smallest positive integer such that 3150 multiplied by y is the square of an integer. A square of an integer is also called a perfect square. Now let's quickly understand what are the perfect squares. So if I were to give the examples of perfect squares, the perfect squares will be like 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 25, 36, 49, 64, etc. Right. But now we have a limitation that we remember only a few perfect squares, maybe up to 25 or someone maybe up to 30. But 3150 into y could be quite a big number. So how do we identify whether the perfect square is being formed by a number or not? So the identification of perfect square is that the exponents of all prime factors, I must say actually the distinct prime factors, must be even. That means if a number is n where its prime factors are a, b, c, etc. and their powers are all even, then it's a perfect square. Now that's the fundamental of perfect square. So what we need to do in this question is we need to prime factorize it first, right? So 3150, the easiest prime factorization is we can write as 315 multiplied by 10. 315 is divisible by 5 again, 5 into 63, and 10 is 2 into 5. 63 can further be written as 9 into 7. 9 I'm writing as 3 square, which means I can write it as 2 times 3 square times 5 square times 7, which means 3150y is 2 times 3 square times 5 square times 7. Now, while we are satisfied by the exponents of 3 and 5, we are not satisfied by the exponents of 2 and 7. The reason is that exponents are 1 each. So what we need here is, we need 1, 2 and 1 power of 7 so that the prime factors 2 and 7 also have even powers. And this must replace y, which means the minimum value of y must be 14 if y has to be a positive integer as it is given. Therefore, the answer to this question becomes option E. So like I said, the perfect square, you can also understand that in perfect cube, all the exponents of all the prime factors must be multiples of 3. And this is one of the fundamentals to absorb and apply in any question of perfect square and perfect cube where needed. Thank you so much.